rectangles denoting terminal stations, diamonds denoting junction stations, and small filled up circles denoting other stations. Look at the diagram. Terminal, junction, and other stations. Each train runs either in the east-west or the north-south direction, but not both. Nice, they don't do this. All trains stop for 2 minutes at each of the junction stations on the way and 1 minute at each of the other stations. It takes 2 minutes to reach the next station for trains going in east-west direction and 3 minutes for north-south direction. So here in this direction, it is 3 minutes between stations. In this direction, it is 2 minutes between stations. 1 minute stop at normal stations, 2 minutes at junction stations. From each terminal station, the first train starts at 6 a.m. The last trains leave the terminal stations at midnight. Nice. Otherwise, during the service hour, there are metro service every 15 minutes in the north-south line, every 10 minutes in the east-west lines. North-south is every 15. East-west is every 10. So there will be a train starting at 6, at 6:10, at 6:20, at 6:30 from here and here, and at 6, 6:15, 6:30, 6:45 and so on here in this axis, both directions. A train must rest for at least 15 minutes after completing a trip. It's tired. Before it can undertake the next trip in the reverse direction. So come from P to Q, I think, and then go back from Q to P. All questions are related to this metro service only. Assume that if someone reaches a station exactly at the time of a train is supposed to leave, he or she can catch a train. The train is leaving at 10:58. I run in, I can get it. Somebody will pull me in rather climatically, wonderfully. And so, nice. And all trains stop for 2 minutes at the end of the junction stations on the way and for 1 minute at each of the other stations. So 2 minutes at junction, 1 minute at others. Just capturing the data. And 2 minutes between stations, train every 10 minutes. 3 minutes between stations, train every 15 minutes. This is the east-west equation, the north-south equation. Right? So just grab the data on. We can't really solve anything and simplify and get a grid and answer. We have to jump through to the questions. First train start at 6, last trains at midnight. If Hari is ready to board a train at 8:05 a.m. from station M, then when is the earliest he can reach station N? M to N. From M to N. 8:05 he is ready to board here at station M. What is the earliest he can reach station N? Right. Nice. So he'll take the straight train here. Right. All we've got to do is, he can't catch it at 8:05. He'll probably grab it only at 8:10. That's when the first train. First train leaves at 8. Second train will leave at 8:10. Because train every 10 minutes in the east-west axis. 2 minutes between stations. I'm going to calculate this. So there are 3 stations here. Say 3 here. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. 1, 2, 3, 4, 5, 5 here. 3 plus 9, 12 plus 5, 17. Plus 2, 19 stations. So 20 gaps from first to end. 20 into 2, 40 minutes. It's just a travel time. Nice. Now we need to think about waiting time. How much time does it take to wait? 3 plus 9 plus 5. This is 12 plus 5, 17 minutes of waiting. 3 plus 9, 12 plus 5, 17 minutes of waiting. Plus 2, 4 minutes of waiting. Just 21 plus 40, 61 minutes. So the moment he boards on to this, 61 minutes later he can reach there. What time does he board on? He can't get on board at 8:05. The earliest he can get on board is 8:10. 8:10 plus 61 minutes. 8:10 and 60 minutes is 9:10. 61 minutes is 9:11. And nice, simple, juicy one to get out of the way, to get comfortable with this. Now we have to register these numbers. 3 stations here, 3 here, 9 here, 5 here, and then we do from one chunk to another, how long does it take to travel, all of that. And so 2 minutes between stations in this axis, 3 minutes between stations in this axis. If Priya is ready to board a train at 10:25 from station T, what is the earliest that she can reach station S? From T to S. Right? She is boarding at 10:25. She wants to reach station S. Right? First of all, she can either go like this and then like this, or like this and like this. Right? I'm going to think in terms of what will be the train that comes to T first. Right? But before that, I understood that there are 9 stations here. Right? So we can say T to V, how long does it take? In between 2 minutes between stations, 10 such stations, 10 to 2, 20, 10 such distances, 10 to 2, 20, plus 9 waiting times. This stretch takes 29 minutes. This stretch, 1, 2, 3, 3 into 3, 9, plus 2, 11 minutes. This stretch, 1, 2, 3, 4, 4 into 3, 12, 12 plus 3, 15 minutes. This stretch, 1, 2, 3, 4, 4 into 2, 8, 9, 10, 11, 11 minutes. So we can calculate each of these stretches and keep them, because we are going to use them in some form or other. First of all, we are going to think about from T to S, is it TVS or TRS, which is better? Right? For which we need to find the train that comes to T, because it's at 10:25. And so P to T is 11 minutes. Starting at here, a train starts every 10 minutes. So at 8 there will be a train starting. At 8:10 there will be a train starting. At 8:20 there will be a train starting. So train going in this direction will come at 8:11, 8:21, 8:31. The earliest in this direction is 8:31. This way, how does it work? There will be a train starting at 8 and then 8:15. This stretch again is 11 minutes. We computed that. So it's 8:11 or 8:26. If it is 8, it is 11 and 26. If it is 10, 10:25, it is 10:11 and 10:26. Straight away, I know that if I go like this, I start at 10:26. If I go like this, I start at 10:31. I have written 8. I'm going to remove that. I'm going to simplify that for myself. (10:31), whereas this axis is 10:26. 10:26 seems juicier, so I'm going to go with that. I'm going to start with that. So with the 10:26, then this stretch, this takes 15 minutes. Why? 1, 2, 3, 4. 4 into 3, 12, plus 3 waiting times, 15 minutes. So it comes here at 10:26. He boards that at 10:26, which is rather nice. And then it's a 15-minute stretch. But there's a 2-minute waiting time at T. T is still a junction station, not a terminal station. So I start at 10:15. I arrive at T at 10:26. I leave from T at 10:28. Take 15 minutes to reach this point. 10:28 plus 15, 38, 10:43. So I'll be here at 10:43. And then I'll have to take a right and go along that direction. That is my TRS route. And so from 10:25, I board at 10:26. It leaves at 10:28 plus 15, 10:43. I'm here, which is rather nice, because my train in this direction will come at 10:41, will wait for 2 minutes. So at 10:43 I come, I can still board the train. So at 10:43 I'll board at R, which is brilliant, which is super useful for me, because now I know there's no waiting time at R at all. So I can ignore this route. As it is, I'm 5 minutes behind. There's a long waiting time at R. I'll have to worry about, is there a shorter waiting time at V? No, I don't wait, because there's no waiting time at R. This is my preferred route. At 10:43 I leave from R. From R to S is 29 minutes. How do I know that? 10 into 2, 20. 10 distances of 2 each, 20. Plus 9 stoppages. At 10:43 I leave from R. I board R at 10:43. I leave from R at 10:43 because it has come to R at 10:41. From 10:43, 29 more minutes I'll be at S and I need to reach S. 10:43 plus 29, 10:43 plus 17 is 11 o'clock, plus 12 more, 11:12 I can expect to be here. My route is TRS because my BT train comes within 1 minute of reaching, whereas my PT train takes 6 minutes. So I can start sooner if I come here. And if I take this option, I'm practically not waiting at R. I get out of my station, run in, board the other station and head out. So both ways it works brilliantly. So 11:12 is the answer I'm looking for. Hopefully that will be there in the choices. It is there. Haripriya is expected to reach train station S late. I didn't understand this question. Late as in what late? What is 2 a.m. late or 6 p.m. late or 11 a.m. late? What is the latest time which we must be ready to board at S? If she must reach station B before 1 a.m. via station R. So she has to come here and come here. She has to reach B before 1 a.m. This question is basically saying work backwards, right? This is 1 a.m. I know this stretch is 11 minutes. This stretch is 15 minutes. 11 plus 15, 26 plus 2 minutes waiting time here, 28 minutes. From the moment I'm at R, 28 minutes I can reach here. Right? So if I want to reach here by 1 a.m., I need to be at R by 12:32. I need to board by 12:32 because 15 minutes of travel plus 2:17 plus 11:28, I'll reach by 1 sharp. 12:32. The last train from here leaves at 12, which will come here at 12:11. There is no 12:32 train to go from A via R to B. That's not possible. So forget about that. So the 12:32 timeline is ruled out. I won't reach at 1 a.m. I'll reach a little sooner than 1 a.m. I have to, otherwise I'm in trouble. So what is the last moment I can board this train at R? R is 11 minutes from A. So 12:11 is when the last train comes here. So if I can board that train, then I'm reaching way before 1. And I cannot catch a train after that because there is no train starting after that from A towards B. So the train that arrives here at 12:11, that's the one I want to grab. Right? Or if I think about it slightly differently, I have to be at R by 12:11 to 12:13. Why? Because this train ARB will wait for 2 minutes at R. So even if I reach by 12:13, I'm fine. So my aim now is to reach R by 12:13. She must be ready to board at station S. So we are looking to board the NSRM train at station S, looking to be here by 12:11 or latest by 12:13. 12:11 is it? I want only the latest time, like I'm playing with the margins. So from S to R is 29 minutes, that I know. So 29 minutes before 12:13 is when I have to board. 12:13 minus half an hour is 11:43. 29 is 11:44. If I board from here at 11:44, at S I get out, I board at 11:42 or at 11:44, it leaves S. It leaves S at 11:44, then I'm still covered because I leave at 11:44, 29 minutes I take, it will be 12:13, 16 plus 13, 29, 12:13 it is about to leave from R, I can reach here. That's the last train leaving at R. So leaving at 11:44 from S, I'm still covered, right? So N to S is 17 minutes. On this axis, we have a train every 10 minutes. So we have a train coming at 11, 11:07, 11:17 at S. And at N, leaving at 11, 11:10, 11:20, 11:30, plus 17 minutes, 11:17, 11:27, 11:37, all of that. So a train coming at 11:37 to S, I should catch. 11:47 at S, I can't catch. So I'm looking to catch the 11:37 train at S. What is the latest time which we must be ready to board on station S? The 11:37 train, but not 11:37, but 11:39, because It is going to come at 11:37 here, and then wait for 2 minutes. Let it become 11:39, and then reach here, and then come back here. And so there's no constraint here because I'll reach way before 1 a.m. This constraint here, I should be before 12:13. I start any time before 11:44. I'm good. The train arrives there at 11:37. I cannot catch 11:47. I'll be late. I'll have to catch 11:37, but I can catch 11:37 at 11:39. I catch at 11:39. I'll be here on time. I'll be here on time. I'm through. The last time you can reach by at 11:39 p.m. What are the minimum number of trains that are required to provide the service on the AB line, considering both north and south directions? Oh, nice. AB line, start from A, think about going to B. Let's think about how long it takes. Right? So this is 11 minutes. This is 15 minutes. This is 11 minutes. 11 plus 15 is 26. 26 plus 11 is 37. 22 plus 15, 37 minutes of this leg, this leg, this leg. What am I missing here? I'm clearly missing a 2-minute wait time here and a 2-minute wait time here. So 11 plus 11 plus 15 plus 4, 22, 37, 41 minutes, which is brilliant. So 41 minutes, and I can go from A to B. The train needs a 15-minute wait time before it can start, functioning. So 41 plus 15 is 56. So if I start a train at 6 a.m. here, that train is ready to start from here at 6:56. Not before that. It'll reach here by 6:41, but at 6:56 he's ready to go back. Not before that. He needs just 15 minutes rest. So my 6 a.m. train should start from here. From starting from B, my 6 o'clock train will start. There's a train every 15 minutes here. My 6:15 train has to start. There has to be a new train. My 6:30 train has to start. That's a new train. My 6:45 train has to start. That's a new train. My 7 a.m. train can be the train that started at A. That means from B, I'll need 4 trains to start before the first train from A comes here and is ready to leave. Not just comes here, it should also be ready to leave. So 6, 6:15, 6:30 and 6:45, I should be ready to start from B before the guy who came from A to B is ready to fire and go. So 4 trains I need to go from B before the first train from A to here is ready to reinforce. Likewise, 4 from here, 4 plus 4, 8 trains are required to provide the service in the city for A, say, for the AB line. How many trains are required? 4 plus 4, 8 trains required totally. What is the minimum number of, say, what is the minimum number of trains that are required to provide the service in this whole city? The AB line is 8 trains. The CD line is 8 trains. These two we have done. If we can crack this, we are through. Multiply that by 2, we are through. Right? From P to T is 11 minutes. T to V is 29 minutes. V to Q is 17 minutes. That's 17 there. So 11 plus 29 plus 17 plus 4. 2-minute waiting time here, 2-minute waiting time here. Add all of this up. 11 plus 29 is 40. 40 plus 21 is 61. Apart from this, there's a 15-minute wait time. So from P to Q is 76 minutes. Or the train that starts from P at 6 a.m. is ready to start from Q at 7:16. 60 plus 16. Oops. So from Q, we need to have a train starting at 6, 6:15, 6:30. Here it starts every 10 minutes. 6, 6:10, 6:20, 6:30, 6:40, 6:50, 6:60, which is 7, 7:10. The 7:20 train can be this one. So 76 minutes or 8 trains. You start from 0, 0, 10, 20, 30, 40, 50, 60, 70. 8 trains need to start from Q before the first train that happened to start from P is ready at Q for the return journey. So this 8 from here, 8 from here. This line requires 16. This line requires 16. 16 plus 16 is 32. 8 plus 8 is 16. 32 plus 16. 48 trains are required totally to service this city. Brilliant, brilliant, brilliant set. Super tough. Super tough. The entire set is super tough. I made so many different mistakes. I forgot the waiting time at the junction. I forgot the fact that the train started 6, 6:15, 6:30. They threw a spanner into the works. The waiting time was very annoying. I consistently made mistakes with that and found answers that were not there in the choices. Lucky enough. Proper.